a function to represent a linear relationship. Think about this question during the lesson. A plan for a skateboard ramp shows that the plywood for the triangular sides of the ramp should be cut such that every 9-inch increase in height is accompanied by a 33-inch increase to the base. What is the height of the skateboard ramp? The first step is to use the graph of a line to represent the situation and to determine the slope of the line. Show the height on the y-axis and the length of the base on the x-axis. We know that when the height increases by 9 inches, the base length increases by 33 inches. So the point with coordinates 33, 9 represents one possible base length and height of the ramp. A second increase of 9 inches in height and 33 inches in base length represents another possible height and base. The line shows that for every 9-inch increase of height, the base length increases by 33 inches. So the slope of the line is the change in height, which is 9 inches, divided by the change in base length, or 33 inches. The slope is 9 divided by 33, which simplifies to 3/11. Now, let's use the slope to write an equation for the function shown in the graph. The equation is y equals 3/11 times x. Y represents the height. X represents the base length. And 3/11 is the slope. Now, use the equation to find the height for a base length of 110 inches. Which variable should be set equal to 110?
Select your answer.
Substitute 110 for the variable that represents the base length, which is x. Then simplify to find that y equals 30. Our results show that the height of the skateboard ramp is 30 inches when its base length is 110 inches.
A skateboard ramp with a base length of 110 inches has a height of 30 inches. A plan for a new ramp requires that for every 3 inches of height, there are 15 inches of base length. Graph the function, then identify the slope of the function and write its equation.
So first we can try to identify our rate of change or slope. It tells us the skateboard has a height of 30 inches. The new ramp requires that every 3 inches of height, there are 15 inches of base length. So that means it's rising 3 inches and then running 15 inches. So our slope would be 3/15, which in turn simplifies That simplifies to 1 over, why is it doing it that way? 1 over 5 is what I'm trying to put in here. Why is it right there like that? There we go. So it simplifies to 1/5. So our slope would be 1/5. So if we start at 0, I'm just going to put this point right here for now. Start at 0 and we go up 1 and then rising 1 and then running 5. 1, 2, 3, 4. Oh wait, this is counting by tens. Always pay attention to how the numbers are increasing because that changes how the points move. So, okay, let's see. So it looks like that's by 10. So in between, we got 1, 2, 3. So this will probably be 2, 4, 6. No, it's not even doing that. Okay. So this will just be 5. Yeah, that'll be 5 in the middle. So we went up 1, and these are increasing by 1. 1, 2, 3. So up 1 and then over 5. So that 5 will be about there. Yeah, 5 would be about there. And then if we did it again, oh no, that'll change it. Okay, I'll leave this here. All right, that's 5. All right, so now we have our line anyway. And so it says identify the slope, which we did, and then we have to write the equation. So the equation would be, type it in. No. Okay, so the equation would be y is equal to 1/5 x. So the x is, yeah, that's the only way I could type it. So y is equal to 1/5 times x. So that is our equation. And then if we were to, if the base length is 110 inches and we wanted to find what the height of that ramp would be, we would use this equation. So the base length is the 110 inches. So then we would, okay, I was trying to type in what you would do. It's not really working well for me. So I'm going to try to write it for you. Okay, so we have y is equal to 1/5 times x. And so it says the height of the, the base length of the skateboard is 110 inches. So we know from the example that the x is our base length. So 1/5 times 110 will give us our y. And so y is equal to 22. So now we have solved the height of the ramp by finding the slope of this function.
The cost to manufacture 5 toys is $17.50. The cost to manufacture 10 toys is $30. Construct a linear function in the form y equals m times x plus b that represents the relationship between the number of toys produced and the cost of producing them.
Step 1, determine the constant rate of change. So to do that, you use that formula we learned in the previous chapter, y2 minus y1 and x2 minus x1. So they've taken the 30, which would be your y2, and subtracted it from 1750, which would be your y1, and took your x2 and subtracted it by 5. So then you get 12 5/10 over 5. Or if you reduce it or simplify it, it's 2 5/10 over 1, which is just 2 5/10. So the constant rate of change is 2 5/10. Now we use that slope and one of the values, so we could take either these values or these values, and they chose to use 30 and 10. So they used the top value there and put it right into the equation y equals mx plus b. So they put the value of x and y, and then you do 2 5/10 times 10, and then that, they don't really show you that part, but 2 5/10 times 10 is equal to 25. And then you have 30 is equal to 25 plus b. Let me write that down just so we're all on the same page. Okay, so, all right, so this is going to be, I'm just going to write it over here to the side. 30 is equal to now 25 plus b. And then remember, from equations, you have to move everything away from your variable. So we're going to subtract, which is the inverse of addition, 25 from both sides. Those cancel out, and then we're left with b, and then 30 minus 25 is 5. So that is how they got 5 is equal to b. So the y-intercept is 5. So the linear function that models this relationship is y is equal to 2 5/10 times x plus 5.
Jin is tracking how much food he feeds his dog each week. After 2 weeks, he has used 8 1/2 cups of dog food. After 5 weeks, he has used 21 1/4 cups. Construct a function in the form y equals m times x plus b to represent the amount of dog food used, y, after x weeks.
So we need to find our slope to help us create our equation to construct the function. So remember, we have y2 minus y1, x2 minus x1. So x. So the first one here, that will be our x1, y1. This will be our x2, y2. So I'm going to substitute these variables with those numbers. So we have 20, 21 1/4 minus 8 1/2. Then we have 5 minus 2. Now we need to solve. 5 and 2 is obvious, 3. And then with the fractions, subtracting fractions, you have to first put them as, these are mixed numbers, so you can put them as improper fractions. Then make sure they have the same denominator to subtract and get your answer. That equals 12 and 3. And then 12 and 3/4 divided by 3 equals 4 and 1/4. So our slope is 4 and 1/4. So now we go back to the equation y equals mx plus b, and now our m is the 4 and 1/4. So we have y equals 4 and 1/4 x plus b. Now it says now that we have our slope, we need to find the amount of dog food used y after x weeks. And oh no, we don't have to solve, so we just use the slope to have our equation completed with the slope. That's it.
The graph below shows the relationship of the height of a burning candle over time. What function represents the relationship?
All right, so I'm going to click on each so you can see information about the graph. So here is the initial height is of 10 inches. The relationship, the candle gets shorter as it burns, so the rate of change is 1 inch per hour. And then the function, you write it as this equation, y equals mx plus b equation. The function is y equals -1 because it's decreasing. -1 times x plus 10, and 10 is your initial height, which is your y-intercept of b. And then final value is after the 10 hours, the candle will be burned completely out.
The graph shows the relationship of the number of pages printed by a printer and the warm-up time before each printing. What function in the form y equals m times x plus b models the relationship?
So the first thing we can find is our y-intercept. And remember, the y-intercept b is where the line crosses the y-axis. So right here would represent our y-intercept of 1. So we're going to have, I'm just going to rewrite this. So we have y is equal to, we don't know what our slope is yet, plus b, and b is going to be 1 because that is our point in which the line crosses the y-axis. So then we need to find our slope. So using the line, we look at how, in this case, it's increasing. So let's see, if I go up 1 and over 2, then that gives me this first point. Let's see if it happens again. I go up 1 over 2, and I keep hitting that line, which means that's my slope. So my slope will be up 1, and I'm rising 1, and I'm running 2. So it's 1/2. So y is equal to, oh, I made a mistake. I said this in another example. Got to pay attention to how the numbers are increasing. I wasn't paying attention, and I would only looked at this side, which is increasing by 1, but this side is not. It's actually increasing each line by 5. So it goes 5, 10, 15, 20, and so on. So actually, when I'm running, I go up 1, that's still correct, but then I'm running, instead of 2, I'm running 10. So my numerator is right, but my denominator should not be a 2, it should be a 10. So y equals 1/10 x plus 1. And so now we have our equation.